Ever struggled to coordinate what files your FastMCP client can actually access when working with a remote server? We'll configure static root directories during client initialization, showing how to explicitly declare resource boundaries that let servers adapt their behavior and responses. This version 2 feature ensures both client and server share the same understanding of available paths up front. From FastMCP import client. Client equals client. My MCP server, pi. Roots equals /path/ to /root1. Path to root 2. This demonstrates the resource boundary pattern through client-declared roots, a feature introduced in FastMCP 2. The concept allows clients to explicitly inform servers about accessible resources at initialization, creating a shared understanding of operational boundaries. Unlike dynamic negotiation, this approach establishes a static contract where clients define the scope of server interactions upfront. The pattern operates through declarative configuration during client creation. By specifying root paths, clients provide the server with contextual awareness about available resources, enabling the server to adapt its behavior or responses accordingly. This separation of concerns means servers can make context-aware decisions without hard-coding assumptions about client environments or requiring runtime permission checks. The primary value lies in creating predictable, scoped interactions between distributed components. While security benefits exist as a natural consequence of bounded access, the core purpose is enabling context-aware server behavior. This pattern shines in heterogeneous environments where servers must interact with diverse client configurations, though it trades some runtime flexibility for the stability of predefined boundaries. The approach scales particularly well in automated systems, where consistent resource availability is more important than dynamic discovery. Let's break it down line by line. From FastMCP import client. Imports the client class from FastMCP, the core interface for MCP server interactions. This class manages connections, request routing, and resource boundary definitions through the roots parameter introduced in version 2. Client equals client. Initializes the FastMCP client with version 2's resource boundary system. The server parameter identifies which MCP server instance to connect to, while roots declares the file system directories the server can access, enabling context-aware behavior and scoped operations. This static configuration establishes the operational boundaries at startup, with each path representing a distinct resource context the server can utilize. My MCP server, pi. Specifies the FastMCP server identifier, typically matching your server's entry point file name. This parameter tells the client which server instance to connect with, establishing the communication channel. For version 2+, the roots parameter defines file system directories that set resource boundaries for the server. This declarative contract informs servers about accessible resources, enabling context-aware behavior while maintaining proper access control. Roots equals /path/ to /root1. Path to root 2. The roots parameter declares file system paths that define resource boundaries for the MCP server. This informs the server about available resources, enabling context-aware behavior and responses while maintaining controlled access. Available in FastMCP 2+, it replaces global file system assumptions with explicit path declarations. Closes the client constructor call, finalizing initialization with the specified configuration. The server parameter identifies which MCP server instance to connect to, while roots define file system directories that establish resource boundaries for context-aware server behavior. This static declaration pattern, available in FastMCP 2+, informs servers about accessible resources upfront, enabling both security scoping and response relevance. Client routes pattern. Routes establish resource boundaries between clients and MCP servers, enabling context-aware behavior by informing servers about accessible paths. The server parameter serves as an identifier rather than strictly requiring a file name match, while routes define the operational scope through either static path lists or dynamic callbacks. Servers use this information to adjust responses and behavior based on declared resource availability.
The boundary that constrains the server liberates the conversation.